So there's a lot of words in this question, but if you read through the wording and compare it to the diagram above, it pretty much is just explaining everything that is on that diagram. So what we have is that Q is at the point 4 meters, and R and P are at 24. The whole platform across is 100 meters. If I take that to be the origin, then B is at 50 and A is at minus 50. So I can write down some coordinates of P, Q and R. P is the point minus 50, 24. R is the point 50, 24. And Q is the point 0.4. I'm looking for an equation of the curve. So the most general equation of a quadratic curve would be y equals ax squared plus bx plus c. I can see that at Q, when x equals 0, y would be 0, so I would have 4 equals c. So my curve is now y equals ax squared plus bx plus 4. If I now plug in at P, I would have 24 is A times minus 50 squared minus 50B plus 4, and at Q I've got 24 equals A times 50 squared plus 50B plus 4. I just tidy those up a little, subtract the 4, I've got 20 equals 2500 A minus 50B, and 20 is 2500 A plus 50B. So from here I could, let's see, we could subtract equation 2, take away equation 1. I would have 20 take away 20 is 0, my a's will disappear, and I would have 50 take away minus 50b, so I would have plus 100b. 100b is 0, so b is 0. If I add them together, equations 1 plus 2, then I would have 40 equals 5000 A divided by the 5000. 4 over 500 is A, or A is 1 over 125. Plugging those back in, I get my equation is 1 over 125 x squared, 0 x, b is 0, and then plus 4. That's part A done. So we found our equation for the curve, and then we're looking at the next part of the question. We've spotted a defect 19 meters horizontally from one of the towers. So we're talking about 19 meters away from there, or 19 meters away from there, and we need to work out the height of the cable at that point. So we're not looking for our x coordinate of 19, we're actually looking for an x of plus or minus 31. So if we pop that into our model, 125 times plus or minus 31, wouldn't matter there, squaring it, and then add 4, and we get 11.688 meters. So that's the height, which is less than 12 meters. So therefore, yes, Lee can inspect it safely. A reason why the model might not be suitable, look for some real life things. Could be weather. If it's windy, it might be unsafe regardless of the height. It could be the model doesn't incorporate the thickness of the cable, platform being absolutely flat, so on. Have a look at the mark schemes. Okay, so some reasons we've got here, the thickness, diameter of the cable not incorporated in the model, whether walkway not completely flat. There may be other examples that would be valid as well. Okay.